So the dimensions for that next patch will be like this only, because I have already copied and pasted that same dimension of antenna of patch. So just in order to displace it on the right side, I am giving it as plus d by 2. Okay, now I'll apply it also. Okay, now we are having a two patches. Okay, so slowly and slowly we will create a our feed network for our antenna array, okay, which is our crucial part regarding that width and of a different feed, different impedance, that 50, 1700 that I've already shown you in the theoretical session as well. So like that you should remember. Okay, now I'll create our feed actually. For that also I will create one line. Okay, now again in the box you have to give the name as feed. Okay, material will be copper only. Color I'm giving again that yellow only. It will be better actually, since I have taken a dark color for that. The dimension for that feed will be that same only, that is minus w minus lp by 2. Wait a second, that cursor is not visible. Yeah, now it will be LP by 2. Why? Because I want this antenna, want this feed at a edge. That edge is located at the LP by 2. As you can see in this second patch, if my cursor is visible to you all guys, then on the right side if you see, this is nothing but LP only. So at midpoint only, at the distance of this coordinate will be nothing but LP by 2 only. Okay, now it is having minus WF by 2 comma TS it will be. Now it will ask for the dimension for the value of the WF, that is feed width. Okay, it is 3.11 if I'm not wrong. Yeah, now I'll give a dimension as LF. It will be 5.9. Okay, now WF will be 3.11. Second will be, that is TP, means thickness of the copper cladding. Okay, that I will apply now. Yeah, as you can see it is coming at the lower side because I have already displaced this patch on the bottom edge, so that's why it is on the left side, so that's why it is coming as like this. Anyway, we'll move this to the left hand side. This also we can do it with the help of this minus d by 2, just in same case what we did in our patch as well, same only we will do. Now this also we will copy and paste, and for this it will be on the d by 2, means on the right side of the patch. Okay, now we have created our 2 patch. Now below we have to make it the 70 and 100 ohm, so that 50 and 100 ohm impedance can be matched with the help of 70 ohm impedance line. Okay, before that we have to extend this 50 ohm feed to the left side and to the right side, and this should be in the left side, so that in the horizontal way we can make the network. Okay, for this extension what I'm going to do, just a small portion having a width exactly equal to this feed only, which is for 50 ohm, that I will going to make on either side of this patch. Okay, that you can see as, first of all I'll rotate it again, because regarding this designing it will be difficult actually sometimes. Okay, that I'll give a name as EXT. Okay, now copper. Okay, now color again yellow only, apply. Okay, regarding this dimension I will give a dimension as minus WF by 2 comma. Why? Because at the x-axis it has to maintain the width only. Once it will be made I will more try to explain it. Then for the TS, again this FE is nothing but feed extension. I am giving a feed extension. just a 2 mm I will give. It is sufficient only. Now further, it will be having a WF x-axis, y size will be your FE only, which is 2 mm, and that is nothing but TP only. Okay, that I will provide. Now it is made in the center only. Okay, now what I will do, I will displace this antenna to the left hand side. This anyway I can make it as 0 comma 0 comma as well at TS also. That is not an issue. That also we can do. If we'll apply, it will be like this only. Okay, that also, this also we can do. And further, now what we do, we will select this ext and edit, go to the edit, go to arrange and move. By this, what it will be easier for us to change it to this edge. Sorry, once again I have to, because I have to match this corner point actually. So again I will do edit, arrange, move. This I will select and this I will displace. In order to check whether it is aligned or not, I will check with the help of rotation option, and I will zoom it further. So yeah, as it is aligned properly. Okay, now let me change the orientation as well, top minus. Okay, be easier. Okay, now same thing has to be done in the other side as well. Okay, that you can do with the help of edit only. This anyway I'll do it once again, CV. Okay, now I'll do edit, arrange and move. This also we can do similarly with this as well. Okay, because anyway it has to be available this side, so that one second, I will change the orientation, Control plus D, in order to fit it in the required area. Again I will check whether it is properly matched or not. Yeah, as you can see in this, it is properly aligned. Okay, now we'll come to the 70 ohm line. For that also we'll go same way in order to design this randomly. First of all, it is the process of the HFSS is totally different from the CST. In that case, we can give directly, no need to draw in a rough manner, and again you have to give the dimension. That is not at all possible. In the CST, you can directly give the dimension. That time it will possible, because, and that too because of this local coordinates also, it is much more similar. In this also relative coordinating system is there, but I'm not using it, so that more features you can see in this as well, how you can move it, how you can shift it, that things you can learn. So I'm giving a name as 70. Okay, and then further I'm giving a material as again copper only. I'll select it, I'll go it. Then the dimension for this, again I will give as 0 comma 0 ts comma ts anyway, for because I'm using the move option, so that can be done easily. Regarding the width, it will be varying in the x-axis, so I'm giving a SW as a 70 ohm feed width. Then length will be SL. Regarding the parameter for the feed width for the 70 ohm is I have given as 1.5. It will be, length will be SL, which I am giving as 10.45. Already I have measured this, so you can also measure it with the help of measure option in the modeler. Okay, that also will show once. Okay, now this has been created. So again I will shift it to the left hand side as well. First of all, I will check whether it is aligned or not aligned. Okay, no issue. 70 0 comma 0 comma ts. SW, SL and TP. Okay. Now we will edit, arrange, move. So we'll select the midpoint for that so that we can arrange it with the midpoint only. Okay. So like that you can do. Same I have to do with the right hand side patch only, patch also. So control plus C, V, then again go to the edit, arrange, move. Again we'll select the midpoint because in case while selecting the midpoint, as you can see in this triangular, the cursor, whenever you will hover the cursor on the edges or the corner points, it will show the square shape only. But once you will selecting the midpoint, it will show the triangular point. So that you can check. Okay. Now, first of one thing I would like to add here that please, while doing this kind of operation, means move, alignment, and all, please check whether that element, that part has been aligned or not. If it is beneath the patch or beneath the substrate, then it will be a problem, and we will not come to know that how it is, what is the reason for this disalignment. Okay. Now our area of concern will be now that is 100 ohm feed. Why? Because 50, 1700. So load is 50, 50 or any 100 only. So Z input will be under root of 50 into 100. Okay, that 50,000 it will come around 5,000 will come around 70.7. So anyway, because we are using 70 ohm, so that's why general way, in general way we are taking it as 70 ohm only. But as you know that in case of theoretical values and comparative to the design values, parameters will deviate. Okay, so for the 100 ohm feed also we'll change it. We'll create a one line. Again give a name as 100, material as copper. Okay, yellow only, and apply. Okay, now the dimension for this 100 ohm will be, I have taken a full dimension because anyway on the either side has to be made, so I have extended the length. No need to create two times for this 700 ohm. Okay, now 100 ohm for this, the position will be same only, 0 comma 0 comma ts. Okay, now it will be HW, which is having a width of 0.72. It will be HL, which is having a length of some around 23.41. Anyway, this length can be extended as well because it will intersect, and anyway at the last we have to unite these all element. Okay, now again you have to shift it to the midpoint, arrange, move. Okay, so for this again select the midpoint and arrange it to the midpoint of this line. One second, again I will do this. Edit, arrange, move. For this, yeah, now it is aligned. Once again I'll check whether it is aligned or not. Now you have to design the main feed where we will excite or we will create our port. Okay, before that what I'll do, again I will ensure it whether these areas have been aligned or not. That I'll check once. Okay, this has been done. Now again I will rotate it, will drag it. Again here also I will check. So it is properly aligned. Okay. Now we'll create a main feed. Main feed is having a length of 3.69.